Okay, so I'm having some technical difficulties, so we're going to do this like this. Um, Today's objective is to be able to use a graphical model to highlight the patterns involved in an electron moving from one energy level to the next in an atom. So we are going to start off. Hold on a second. Let me get rid of this. So, come on. So we are first going to review how to convert from electron volts into joules, because you'll need to know this for later in the video. So first we just take 2.1 electron volts and multiply that by 1.6 times 10 to the negative ninth joules per electron volt, and that becomes 3.36 times 10 to the negative 19th joules. And then we can convert that into frequency using energy is equal to Planck's constant times frequency, and that is 9.25 times 10 to the 14th hertz. So then these energy level diagrams, they're specific for each type of atom, and in your reference table, there's only two. There's one for hydrogen and there's one for mercury. The n equals 1 state on the lower right hand corner for each of these is the lowest possible energy for an electron in that atom, and that's known as the ground state. This energy corresponds to n equals 1. And the energy levels are negatives because that indicates the electron that's being bound by the nucleus of the atom, and it's going to get released. So if the electron reaches 0 electron volts, it's no longer bound by the atom and it can be emitted as a photoelectron, or it can be ionized. And any remaining energy becomes kinetic energy for the photoelectron. Then we have quantum theory, which we haven't talked about much before, but it says that photons have only a set amount of energy depending on the frequency of the light. Each packet is a quantum, and Max Planck's constant, which is the h, tells us how much energy each quantum has. Energy levels: when an electron accepts a photon, it will jump up to a higher level. When it emits a photon, it will jump down to a lower level. So we've talked about photoelectrons, the photoelectric effect, and this is where we're going to be talking about with specific energy levels. Each energy involved in jumping orbits corresponds to a specific energy. So for hydrogen, the work function is that 13.6 electron volts, which is, if you look here, 13.6 is that this is hydrogen. It's the ground state. So that's what you need in order to release it from the ground state. So that's what that work function means. And then it's a negative number because you need to give it 13.6 electron volts just to get it up to the 0 level where it would escape. There are energy levels under the work function where the electrons jump up and drop down, but they stay attached to the atom. It's not enough to make it leave the atom, so we don't worry about them. So here is going through all of the hydrogen atom, and this is basically it's like expanded a bit so that you can see it a little easier. It says for A right here, the electron will require a photon with an energy of 10.2 electron volts just to get to n equals 2. So it's the 13.6 electron volts, and then to get up to n equals 2, which is 3.4 electron volts, you subtract them and you'll get the 10.2 electron volts. So that's what it takes to get from n equals 1 to n equals 2 energy level. And then the electron that's released, if it releases that photon, if the electron releases a photon of 10.2 electron volts, it will return to the ground state. And then you can go through each of these energy levels, and that's what's happening in hydrogen. So here is a quick example problem. It says an electron in a hydrogen atom drops from the n equals 3 state to the n equals 2 state. Determine the energy of the emitted radiation. So the equation we have is the energy of the photon is equal to the initial energy minus the final energy. So then it's the negative 1.5 electron volts because it started here and it's going down to the 3.4. So then negative 1.51 minus the negative 3.4 electron volts is 1.89 electron volts. And then what is the wavelength of that emitted radiation? You can use energy is equal to hc divided by lambda, and you get 6.56 times 10 to the negative 7th meters. And that's all I have. Thanks.